Hi everyone, let's talk about atmospheric conditions. So last video we talked about lapse rates, and this video it's going in depth in them, talking about the variations in lapse rates. So number one, you have absolute stability, absolute instability, and lastly, conditional instability. Looking at absolute stability, it's when the absolute value of DLR is greater than ELR. This means that your parcel of air decreases more temperature as it increases altitude than your atmosphere. So if it decreases way more per altitude, it's going to be to the left of the ELR, like this. So if that is your DLR sign, that means your parcels of air are always colder than your environment, and therefore your air is sinking. So this is usually associated with high pressure systems where the air is sinking, and when you get sinking air, it doesn't want to rise. So when the air sinks, it actually increases in temperature and it doesn't condense. And therefore, you have clear skies, you have calm weather, and you get the occasional drizzles. But generally, it's 99.99% clear skies because you barely get any condensation. For absolute instability, it's where your DLR and SAR are both less than ELR, which means that for your parcel of air, at first, it decreases at a rate slower than your ELR, so it's something like this. This causes your parcels of air to rise and rise and rise because they are warmer than your environment, and therefore you eventually get to dew point on your lifting condensation level, which means you're able to get saturated parcels of air and SALR. You can see when it overtakes, your parcel of air is always warmer than your environment, and therefore your air will keep rising and you get condensation everywhere into tall cumulonimbus clouds, and you get a lot of rain, very unstable conditions. Lastly, for conditional instability, it's actually similar to your absolute stability one, where your DLR is to the left of ELR, like this. So you get clear skies, you get very peaceful weather, but something happens that forces the air up into higher altitudes, which means it has to reach dew point because it's colder. Any air that gets forced up has to be colder. It reaches dew point and it starts to condense with SALR. So SALR starts to get drawn, and it will be steeper than your ELR, like this, and eventually overtake it. So what happens here is your air wants to sink, right? So it's not condensing at all over here, but something happens that forces the air up into dew point, and it minimally condenses here. But when it starts to become warmer than your environment, it will start to rise and condense even way more. So you get a bit of calmer conditions over here in the middle, but you start to get a lot of clouds here, and you get some clouds at dew point. So as you can see here, air, it will eventually condense up here, and sometimes it's cloudy, sometimes it's clear skies. It depends on the condition. And down here, I drew two conditions. Number one is frontal uplift. So you have a cold front and a warm front. So you have cold air here, warm air here. The warm air is still much more colder than the environment, so it wants to sink. But if it meets a cold air front, it has to displace, and it has to be higher than the cold air because it's warmer and it's less dense. So as they meet, the warm air is pushed up. Even though it's over here, it gets to push up to high altitudes, and it eventually reaches dew point, and then it starts to condense and get into SALR, which is to the right of ELR, and therefore you get a lot of rising and condensation. So that is frontal uplift, whereas number two is orographic uplift, which is all about mountains. So again, you have cold air pushing towards the coast or something, or towards mountains, and when they meet mountains, they can't just pass through the mountains. They have to go over the mountains, and when they go over the mountains, they are forced up to higher altitudes. Some mountains are thousands of meters high, and therefore you get pushed up to higher altitudes. and you push up to above dew points and you start to condense. So these two are the main conditions for conditional instability, and they cause areas where there is stability to be unstable sometimes. So this sums up the 3 types of atmospheric conditions due to lapse rates. I hope you guys enjoyed, and I'll see you in the next video.